And make this as neat as possible. Now, this is how I tested out of math classes when I was in my early 20s. I only had a GED, but I went to a major university, only armed with a GED, and I passed the SAT test. I scored high enough to get in, and then I tested out of 3 mathematics classes. I tested out of intermediate algebra, college algebra, and geometry. Well, college algebra also included trigonometry. And I only studied a month before I did that. Imagine being armed only with a GED and going to a major university. I'm going to try to make this as neat as possible, but it's kind of hard to hold the camera and do this too. I mean, I could invest in better software, but right now, currently, I just don't have the time. I have the money, but I don't have the time. So, but I will get around to it eventually, because I would like to start tutoring people professionally online. Let me tell you something, people. Don't drink alcohol, because alcohol screws with your logic skills. I try to tell people that. I try to tell young people, don't drink alcohol, because alcohol will mess with your logic skills. And it can cause you to become slow, intellectually slow, and to make dumb mistakes in life. Alcohol is the worst thing. I found that out the hard way. I mean, because I actually got to where I couldn't even think. And I was great in mathematics. Great. I mean, I'm talking about I could do anything that I wanted to with it. I mean, I was solving some of the most advanced problems in mathematics in the world. But I started drinking, and that was a bad thing to do. Bad thing to do. So anyway, I'm going to try to explain how to do this. I'm going to try to be as neat as I can, but it's kind of hard to hold this camera and do this too. So, but I'm trying to make it kind of really visible. Okay. And on the test, I would really go fast. Really go fast. And now this camera, it's hard to hold this and do this at the same time and make it neat enough to where it's really. So I'm trying to darken everything so that it comes through clear. Okay, we're going to call this theta. Now keep this in mind. Theta plus alpha plus beta is equal to what? Well, that's a right angle. So it has to equal 90, right? In that case. Okay, just keep that in mind. I'll come back to it later. Okay, now I want to use some trigonometry. Well, the side opposite divided by the hypotenuse. This is supposed to be a right angle here. So when you're dealing with the hypotenuse, so the side opposite divided by the length of the hypotenuse is sine alpha. So, right? So side opposite divided by hypotenuse, which is 1, equals sine alpha, which you can automatically see that the side opposite here is just going to be sine alpha, because I'm using a hypotenuse, a unit hypotenuse equal to 1. Let's assume that that's equal to 1. Now, I didn't measure it out. I just drew it. But I'm going to assume that it's equal to 1. Okay, so we're going to say that that is going to equal to sine alpha. Okay. Now, then that means automatically this is going to be cosine alpha, right? Because that's the side adjacent, right? So, the side opposite over the hypotenuse equals sine alpha. the side adjacent, or next to the angle, over the hypotenuse, equals the cosine of alpha. Okay, now what I need to do is I want to mark off this distance here. And I'll show you why in a minute. Okay, and I want to mark off this distance here. Okay, that means I'm going to have to figure out this length here. Well, that's pretty easy, because this becomes the hypotenuse of this right triangle. So, side opposite beta over the hypotenuse, side opposite over the hypotenuse, which is cosine alpha, equals sine beta. So what's that going to be? That's going to be sine. I'm going to write it like this: sine beta times cosine sine beta times cosine alpha, like that. Okay, with that said, I want to find this distance here. Well, now let's think about this. This angle here is going to be the complement of a right triangle. So that means we have the angle beta here, and this is 90 degrees, so this angle has to be 90 minus beta, right? Okay, so that angle there turns out to be 90 minus beta. And for now, I'm going to call this angle here x. Okay, I'm just going to call it x, okay? So I want to find that angle there, okay? So how am I going to find that angle there? Well, I mean, isn't it true that this angle plus this angle plus this angle is going to be 180 degrees because it's a straight line? Well, okay, so now we're going to have 90 minus beta plus 90 plus x equals 180 degrees, right? See that? This is the complement. The complement of this right triangle with hypotenuse cosine alpha and angle beta. See this angle beta? This angle beta. So 90 plus beta plus this would be 180. So that means this equals 90 degrees minus beta. Okay, 90 degrees minus beta, which I have right here. Okay, and I said this angle plus this angle plus this angle is 180 degrees, right? So that's what I just did. 90 minus beta is this angle here, plus this 90 degree angle is here, plus this x. All three add up to be 180 degrees, right? Now I can combine these 90s and I get 180 minus beta plus x equals 180. I subtract the 180s from both sides and I get negative beta plus x equals 0, which proves that x equals beta. Pretty cool, right? Okay. So this x is in fact going to equal the angle beta, which is right here. All right. Well, what does that tell me? Well, I know this hypotenuse of this triangle is sine alpha. So, side adjacent over the hypotenuse will equal cosine beta. Okay? Side adjacent over the hypotenuse, which is sine alpha, equals cosine beta. Ooh. Can I write that as that side adjacent is going to be equal to sine alpha cosine beta? Well, sure. If I multiply both sides by sine alpha, then I'm going to get cosine beta sine alpha, which is the same thing as sine alpha cosine beta. So I'm going to say in here we have sine alpha cosine beta, correct? Okay. Isn't it also correct that the sum of these two is going to equal to the entire length of this here? Sure it is, right? So, excuse me. With that said, what is theta going to equal to here? Well, theta is going to be 90 degrees minus alpha minus beta, right? Theta, that's going to be theta. So now what do I need to find? Well, to get a side opposite, I need to find this angle here. So we know that theta plus some angle, let's call it z for now, plus 90 equals 180 degrees, right? So z is going to equal to 180 minus theta minus 90, correct? But what did we say theta was going to equal to? 90 minus alpha minus beta. So z, that angle z there, we're calling it z for now. We're going to call that angle z for now. Okay. So obviously, angle z is going to equal to 180 minus this 90 minus alpha minus beta. 90 minus alpha minus beta, sorry. Minus 90. And we solve it, and we get 180 minus 90 plus alpha plus beta minus another 90. Okay, so now we're going to add everything up, and we're going to have 180 minus negative 90 plus negative 90 is 180 plus alpha plus beta. Ooh, interesting, because these are going to cancel, and there's your angle, alpha plus beta, right? So z is going to equal to alpha plus beta, correct? So now what are we going to have? Well, we're trying to find, we're saying that the side opposite over the hypotenuse, this length here, is going to equal to the sine of alpha plus beta, right? So the sine quantity alpha plus beta. But isn't it also true that this length here is equal to this length here? So we're going to add everything up. So now we're going to say, only I'm going to go the opposite direction. I'm going to say this plus this. So I'm going to say sine alpha cosine beta plus sine beta cosine alpha. Isn't that cool? Cosine alpha. Well, now we're getting somewhere. There's the double angle formula for the sine function. What happens if we let alpha equal to beta equal to phi? Okay, like that. And we have phi in there. So if alpha equals beta, we're going to have sine 2 phi is going to equal to sine phi cosine phi plus sine phi cosine phi. And we add these two together, we're going to get sine 2 phi equals 2 sine phi cosine phi. Wow, there you have it. The double angle formula for the sine function. Sine 2 phi equals 2 sine phi cosine phi. So if you've seen this in calculus, you would know that 2 sine phi cosine phi equals sine 2 phi. And you could let that equal to x or whatever, say you want to let phi equal to x. And you could write it as sine 2x equals 2 sine x cosine x. And if you see this 2 sine x cosine x. How do I integrate that? Well, you know it's going to equal to sine 2x. And then you would let u equal to 2x, and you would do it that way. Okay, so that's how to figure out how to derive the double angle formula for the sine function. And I use reasoning like this when I tested out of classes. I would just sit down and just draw it out and use reasoning like this, and I would find a formula and several different things, you know. So that's how I did it. Okay, thank you for watching.